be the change I want to see. To do with strength and wisdom all that needs to be done, and become the whole that I can be. Set me free from my fears and hesitation. Grant me courage and humility. Fill me with spirit to face the challenge and start the change I long to see. Today I start the change I want to see. Even if I'm not the light, I can be the spark in faith, service, and communion. Let us start the change we want to see, the change that begins in me. Today I start the change I want to see.
Even if I'm not the light,
I'm not the light, I can be the spark. Faith, service, and communion. Let us start the change we want to see, the change that begins in me.
Jesus in us.
Jesus in us.
Good day, students. Today we will have a new topic. But before that, let's have Miss Cha for the review of the previous lessons.
For term 4, we discuss about fundamental counting principles, factorials, and permutation. As a review, let's watch this video.
Fundamental counting principle. It states that if an event has m possible outcomes and another independent event has an n possible outcomes, then there are m times n possible outcomes for the two events together. This rule can be extended to any number of events occurring in sequence.
Factorials is denoted by this symbol, exclamation point. Okay, so let's go first with its definition. For any counting number n, for any given number n, the product of all counting numbers from n down through 1 is called the n factorial, or written like this. So n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 and so on until we get multiplied by 2 down to 1. Permutation refers to the arrangement of objects. When we say arrangement, order matters. So this is the difference between the combination and permutations. In permutation, order matters. So it comes from the word to permute, which means to arrange. So these are the words that you need to remember in dealing with permutations.
Circular permutation. It is the total number of ways in which n distinct objects can be arranged around a fixed circle. The formula that we will use is P is equal to n minus 1 factorial. Permutation with repetition or distinguishable permutation. It is a permutation with identical elements. We will use this formula where n is the number of items and r sub n is equal to the repeated items.
So thank you, Miss Cha, for that review. Next, let's have our new topic. It's all about combinations, and Sir John will take over.
Thank you, Sir Gino. Now, for this week's objective, we are expected to solve real-life problems involving combinations. Now, let's have this video.
A combination is an arrangement of objects in which order does not matter. Since the order does not matter in combinations, there are fewer combinations than permutations. The combination is just a subset of permutation. Since we all know what permutation is, this lesson will be much easier for us. The number of distinct combinations of n distinct objects that can be formed taking them r at a time is this formula: n factorial divided by r factorial multiplied to quantity of n minus r factorial. Let's have this example. 3 members of 5-person committee must be chosen to form a subcommittee. How many different subcommittees could be formed? So remember, the order is not important in this example. So just substitute values. We'll get 5 factorial over 3 factorial times quantity of 5 minus 3 factorial. So 5 factorial means 5 times 4 times 3 times 2 times 1. 3 factorial means 3 times 2 times 1. 5 minus 3 is 2. 2 factorial is 2 times 1. Before proceeding to the next step, we may simplify this fraction by cancelling 3 times 2 times 1 in the numerator as well as the denominator. So we may get 5 times 4 over 2 times 1, which is also 20 divided by 2, which will give us 10. That means there are 10 different subcommittees that can be formed from this 5-person committee. Next example. In how many ways can 12 players can be selected from 20 men who tried out for the basketball team? So again, we just substitute the given values to the formula. So we have 20 factorial over 12 factorial times 20 minus 12 factorial. So you may use your calculator, by the way. If you're done, check if you have the same answer. 125,970. Now you may try this on your own. A basketball team consists of 2 centers, 5 forwards, and 4 guards. In how many ways can the coach select a starting lineup of 1 center, 2 forwards, and 2 guards? Now first thing, you may consider dealing with the center position first, then the forward position, then the guard position. First, for the center position, you have 2 options, but you must choose one. So you'll have 2 factorial over 1 factorial times 1 factorial, which is equal to 2. For the forward position, you have 5 choices, but you must choose 2. So you'll get 5 factorial over 2 factorial times 3 factorial, which will give you 10. And for the guard position rather, you have 4 options, but you must choose 2. So you have 4 factorial over 2 factorial times 2 factorial, then you get 6. Now to get the final answer, you have to multiply these combinations to each other so that you get the number of ways to select the starting lineup is 2 times 10 times 6, you get 120. There are 120 ways for you to select the starting lineup from this pool of players from your basketball team.
Thank you, Sir John, for that amazing discussion. I know you students learned something new today, but a simple reminder from Miss Cha. Here we go.
Please be reminded about our 4-term activities for gateway assessments 2 discourse assessment, and 1 integrative assessment. The deadline for submission is May 17, 2021.
Thank you for that, Miss Cha. Now, my dear students, if you have any questions or clarifications, kindly message your own subject teacher through SB message or through MS Teams. Thank you. Goodbye. Bye-bye.